Hi students, today we are introducing two more derivative rules that we're going to prove and then take a look at some more derivative shortcuts. We're going to start out by looking at the derivative of these two functions, f of x and g of x, and try to do this with the definition of derivative. So we're talking about the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x and g of x all over h. And that looks like a mess. All right, to be able to simplify this, we're going to do a really weird thing. We're going to add and subtract the same thing to try to make this thing a little bit more factorable, a little more friendly. In doing that, I'm going to take the limit as h approaches 0. I'm going to build my fraction. I'm going to put f of x plus h times g of x plus h and minus f of x times g of x at the front and the back. And then I'm going to add, subtract the same thing in the middle. What I'm going to add and subtract to this thing is going to end up being minus f of x g of x plus h and plus that same thing. I really didn't leave myself enough room here, I'm sorry. F of x g of x plus h. What I'm going to do with that is break that into two separate pieces so that we have the limit as h approaches 0, and that first piece is going to be f of x plus h times g of x plus h minus f of x times g of x plus h all over h. And then the second half of this, starting with my other term here, that's supposed to be an arrow, not a minus. So we've got plus f of x times g of x plus h minus f of x times g of x. Again, in the realm of proving these things, these are not things that I expect you to be able to do or even replicate on your own. This is something that I hope that you can follow along and see where these steps came from. So here we have mysteriously added and subtracted something so that we're not actually changing the value of this. And as we go through this, now we're going to try to simplify some things. All right, I noticed that in my first term, I've got a g of x plus h in common. So I'm just going to rewrite my limit. As h approaches 0. G of x plus h, I'm going to factor this out. I'm going to factor this out of the whole thing, kind of keep that out in front. And then left in the inside is going to be f of x plus h minus f of x and then over h. So this is really g of x plus h over 1. Multiplying that through would get us back to our original statement. Cool. Then I'm going to look at the second part of this. And actually, at this point, I'm also going to break this into two separate limits. We know that the limit of two things being added is the same thing as the limit of each of those separately. So we've got the same type of thing. I've got an f of x common in both of these. So I'm going to put f of x over 1 out front. And then multiply this by g of x plus h minus g of x over h. And my hope is that we can see that the limit of this lovely friend is going to be a derivative. The limit of g of x plus h is just g of x. And we have our derivative of f of x. I'm going to write that as f prime of x. And on the other one, as we plug 0 in, F of x stays f of x. That's kind of nice. Got my plus in between there. And then this is the derivative of g of x. What I'd like us to notice, I'm going to write this in a way that kind of makes it a little bit easier to remember, is that we have f prime of x times g of x plus the derivative of g of x times f of x. So f prime g plus g prime f. This is the derivative of f of x times g of x. This is called the product rule. It's the first of kind of our fancier derivative rules, and we use this whenever we're multiplying two functions together. We're about to do the same thing we just did, but now we're going to do this to discover what happens if we're dividing two functions. So let's set up our limit. Limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. Ugh, that's kind of gross. Let's see if we can maybe combine some fractions up top, and that might make this a little bit nicer to look at. So the limit as h approaches 0, I'm going to multiply the left by the right bottom. So we got g of x times f of x plus h, and that's over g of x plus h times g of x. On the right side, we're going to have f of x times g of x plus h. And on the bottom, we're going to have g of x plus h times g of x. And that's still all over h. I'm going to combine my fractions, and since we're dividing by h, that's going to live on the bottom. So we're going to end up in the next slightly simpler step. The limit as h approaches 0 of g of x times f of x plus h minus f of x times g of x plus h all over h times g of x plus h times g of x. Okay. We're going to do something really similar to what we did in the previous problem, where we had adding and subtracting the same thing to try to get these things to make some sense in terms of derivatives. I'm also going to pull out the bottom part of this that's not h, and deal with this as the limit as h approaches 0, 1 over g of x plus h times g of x. That's not going to come into play until the very end of this. And the things that I'm going to add and subtract here are going to end up being, we're going to add and subtract f of x, g of x to this numerator. Okay, I'm going to regroup that with things that can factor. I also know that I want things to be subtractable within this. So that means that my second term that I wrote here is going to get grouped with my first term there, so that they both have a g of x and that there's subtraction between them. That's going to become, I did not mean to still be in highlighter mode, g of x times f of x plus h minus g of x and f of x. I was right, g twice. All right, that's going to be over h. And then next to this, we're going to end up having, I'm going to make this minus just so we can have these things as positive in front. So that's f of x, g of x plus h. And since I'm making this whole fraction negative, that's going to take this positive and make it negative as well. And that's going to be f of x, g of x. Beautiful. I've got f of x in both of those. We have two separate fractions. Now we're getting somewhere. We may not be getting somewhere extremely beautiful yet, but we're getting somewhere. If I look at the top of this, you might notice, I'm going to rewrite this. I like that I start a sentence and then realize I had to rewrite stuff. That's always a fun thing to do when recording a video. I'm going to factor out a g of x. And I'm left with, unsurprisingly, f of x plus h minus f of x over h, which should look really familiar at this point. I'm going to factor in f of x out of the next one. And I end up with g of x plus h minus f of g of x, also over h, and that should also look really familiar. Let's slide this up a little bit and look at what we have. Okay, taking this limit now, we're going to end up with 1 over, well, that's going to become g of x times g of x. Hope you're okay if I instead call that g of x squared. G of x doesn't change, so it's going to just kind of live there. This is the derivative of f of x, so that's f prime of x. We are subtracting. F of x doesn't change if h approaches 0, so we've got f of x. And then we've got, this is the derivative of g of x. Cool. So g prime of x. I'm going to rearrange this a little bit to make it easier to remember, and then we're going to compare the product rule, which we just did, and the quotient rule, which this is. So this is the derivative of f of x divided by g of x. And what we end up with is f prime of x times g of x minus g prime of x times f of x, and that's all over the bottom squared. What I'd like you to notice is how similar this is to the product rule. We know that products and quotients are related. It makes sense that their derivative rules are connected as well. And the product rule, if I'd like you to recall, so the derivative of f of x times g of x is going to be f prime g plus g prime f. Here I've left the of x's out because I ran out of room. In terms of the quotient, if we wanted to shorten that notation a little bit, you're welcome to do so. We end up with f prime g minus g prime f. Same exact thing as the product rule, but switched signs. So we're subtracting instead of adding. But then we're dividing this by whatever g is squared. This product rule and quotient rule are two of the derivative rules that are most important that we're going to be using this year, because they can be applied to any type of family of function.